Hi, we are going to do now 8M4, lesson 16. Say it with me, the computation of the slope of a non-vertical line. Now, the good news is we did most of this in lesson 15 already. This is just a kind of a more, I don't know, it's just kind of a refresher. We're going to review in maybe a little bit more formal notation exactly what the formula is for computing a line, but there's not a lot of new stuff here, but there is some good homework help that you may want to check out if you want to just fast forward to that. Otherwise, I'll kind of review the lesson a little bit. Today's lesson, you probably sat in class and you calculated, you looked at some graphs and you did some calculations and found slopes. You found slopes using multiple different points on the line, but let's get to it and do the work. All right. Here we are on our sketch pad. Okay, so this is not where we're going to start. This is where we're going to end. We're going to start over here with a quick lesson 15 review. So we learned, let's see. So let's switch to a different color. Let's go to red. We learned that to calculate the slope of a non-vertical line, you can even try it for a vertical line, and we're going to try it later on at the end of this lesson, and you're going to see why we specify non-vertical line. You perform these steps, and then we're going to do this over and over again today. You, A, choose any 2 points on the line. B, you find the rise over the run, or the same thing is the change at the delta y over delta x, or the change in y over the change in x. And then C, you simplify, and you find that as a fraction, and then you simplify the fraction. So that's what you do over and over again. Now, another word, recall what is another word for the slope, the rise, the run, the delta x over delta y. This is also, the code name is m. M equals the symbol that means slope. So when I talk about m, rise over run, delta x over delta y, that all means the symbol that defines a slope. Now, one way that we can formalize, let me just formalize this for you, and this is something you're going to see in math classes in years to come, is you're going to see this formula that says m, which is the slope, is equal to y2 minus y1 over x2 minus x1. And this is called the slope formula. And all this is doing what we already know how to do. And it's just a formal way of stating it. Okay, so if we have our axis, and on that axis we have a line that looks like this. Why did it not draw it in green? I don't know. Let's make it be green. And we have a line, and we have a point right here, and a point right here. This point here, we're going to call this point 1. So that's going to have coordinates of x1, comma, y1. That's a comma. That's the next one, comma, a y1. Kind of hard to read. It's comma. You know what? I'm going to make this so obvious you can't possibly miss it. This is going to be x1, y1, and this is going to be x2, comma, y2. But watch how I make it obvious. I'm going to switch colors. So this is x2, comma, y2, and this is x1, comma, y1. And the way that you find the difference, you find that rise, if this has a y coordinate of y1 and this is y2, this rise here is equal to y2 minus y1. So that's the rise. This is nothing more than the rise. And then from here to here, that's your run. And that's found by the change in your x coordinates, x2 minus x1. So that's your run. And so that's where we get this formula of m equals y2 minus y1 over x2 minus x1. Okay, so let's put this in our memory bank. Let's remember these steps, and then we're going to get with it. Okay. So now notice that when you're applying this slope formula, we're going to write it again. M equals y2 minus y1 over x2 minus x1. Now remember, you can always remember the y is on top because that's the rise. If you can remember the phrase rise over run, if you can remember that, it's alphabetical by the way, rise comes before run, rise over run, you can always think about if you take your 2 points, you're going to find the rise over the run. And the rise, this is your y values, right? Because this goes in the same direction as the y-axis. And then your run here is your x, which is the same direction as your x. So rise over run, your y's over your x's. Okay. Now, the interesting thing is you can actually call this one x1 and y1, and this x2 and y2 in this formula. Or you can call this one x1, y1, and this one x2, y2. It doesn't matter. You can use it this way, or you can use it this way. And maybe this doesn't make a lot of sense to you right now, but we're going to go through this in the upcoming examples, and you're going to find that this slope formula is so cool because you can use any 2 points on the line. You could use this point, this point, this point, this point, any of those 5 points, any 2 of those 5. And then you can also do them in any order. So you can do this one, this could be point 1, and this could be point 2, or this could be point 1, and this one could be point 2, or this one could be point 1, and this one could be point 2. Doesn't matter. You'll always, 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 any 2 points in either order will always give the same slope. Okay, let's see how this works. So we're going to call this homework help because this is what the homework problems are all going to look like. So let's find the slope of this line. Oh, well, I've already written it down. So find the slope of this line by using 2 points. Find 2 points. And the easiest thing to do is find 2 points that go across an integer boundary. So don't choose this one. Don't choose this one because although you have an 8, an integer 8, you're going to end up with some kind of weird fraction that you don't even know for y. So don't use that. Find a point like this one. It's on an axis. Okay. And then I want you to use 2 different points, and then you find the slope of this line and verify that you get the same answer as you did in A. Now let's recall. I'll write it on the first one here. The slope formula looks like this. And you know what? I'll go ahead even and give you x1 and y1 on this first one. And then I want you to find 2 different points and we'll calculate it a second time. So this is x1, y1, and that's going to be 4, 0, and x2, y2 is going to be 9, 2. Okay, so I'm going to let you go ahead and try and find the slope of this line. Okay, so pause and try, and we'll come back and we'll see what happens. Okay, I assume you've tried it, you found the slope, and you're all happy, and you've maybe even gone ahead and you found 2 other points, maybe this point and this point, and gone ahead and calculated the slope a second time. So we're going to do that. We're going to use these ones way apart and see what happens. Here, I'll just mark them right now. So if those of you who want to go ahead and find this one also, go ahead. Okay, so right now, though, we're going to use these 2. So y2 is 2 minus y1 is 0 over x2 minus x1. And so we get 2 over 5. So our slope is 2/5. And that's the answer to A. Now I'm going to use these points way apart, and we're going to see if we get this 2/5 again. Hopefully we better, because the rule is you always should get the same number. Now I'm going to even go backwards. I'm going to make this be 0.1 and this be 0.2. So this is going to be my x2, y2, and that's going to be -1, -2. And up here I'm going to have 14, 4. And that's my x1, y1. Okay. So now if I'm going to do this one first. So my y2 is -2 minus 4 minus my 4. Now we'll subtract my x's. -1 minus 14. This is my slope. Well, -2 minus 4 is -6. -1 over -14 is -15. Well, that doesn't look like 2/5, but we haven't simplified. Well, a negative divided by a negative is a positive, so these will cancel. So that's 6 over 15. Now I can divide the top and bottom by 3. And I get 2 over 5. Cool. I expected to get the same slope, and I did. So we are going to give ourselves a giant happy cat for getting the same answer and answering A and B correctly. Awesome. Now we're going to do the same thing on this next problem. I want you to use 2 points on this line. There may only be 2 that actually meet the criteria of lining up right on integer boundaries. And then I want you to calculate the slope again, switching the order of the 2 points. Use the same 2 points and do it both ways. Remember, so I want you to m equals y2 minus y1 over x2 minus x1. Do it both ways. Let's see what happens. Okay, I'm assuming now that you are paused and you tried. Okay, well, there's only 2 points. Now let's go and solve this. Let's do A. There's only 2 points that I've identified that are actually neatly on a boundary, and that's these 2. So let's call this, we're going to start with this being 0.1 and this one being 0.2. So if this is 0.2, I'll get my y2, m is equal to y2 minus y1 over x2 minus x1. And so my y2 is 1 minus 6 over my x2 is -7 minus -9, minus -9. Now, before we go too far, I know that this slope is going down. So I am expecting that my answer is going to be negative. My slope better be negative. If it's not negative, I've done this wrong. So 1 minus 6 is equal to -5. And -7 minus -9 is -7 plus 9. So that's -5 over 2, which is -5/2. Now I'm going to do this the second way, and I'm going to switch my x's and my y's. So I'm going to start here. This is going to be my 2, and this is now going to be my 1. So now we have m equals 6 minus 1, my change in my y's, over my change in my x's is -9 minus -7. So that's equal to 5 over -2, which that's not simplified yet because negatives can't be on the bottom. So that's equal to -5/2. And we are going to happy cat that one because we got the same answer. So that's what this whole lesson's about, just calculating slopes on lines. Now I want to go one more step, and I want to do the confusing thing. And this is actually, I think there's a problem like this on your homework, so this is not a waste of time. And this is good knowledge anyway. No math is really a waste of time. So can you find the slope of the blue line, why or why not? I want you to try and find that. I want you to pause now and try. And I'm going to even give you 2 points. Let's use this one, 3,6, and this one, 3,2. Let's use those 2 points. So now pause and try. To find the slope. Okay, so let's recall. I'm assuming you've done this. So let's try this. y2 minus y1 over x2 minus x1. So my change in y's is 6 minus 2. My 6 minus 2, change in y's, over 3 minus 3. Well, I get 4 over 0. Well, this is a problem. This is a big problem. You cannot divide by 0. So a vertical line, and you'll notice it doesn't matter where this line is. If this line was over here, or over here, or over here, any vertical line will have this problem where you divide by 0. And a number divided by 0, we call that undefined. Undefined. That's the value. That's that's what you get when you divide by 0. That's not a number, it's undefined. So all horizontal lines, all vertical lines, and this is the key, this is key point. All vertical lines have an undefined slope. Now, what I want to do to summarize and end this lesson is go through the 4 line types. These are our 4 line types, and I want to remind us what is true among these lines. A line either goes up from left to right, goes down from left to right, and we learned about that 2 lessons ago, or it's straight up and down, or it's horizontal. And let's remember, things that go up left to right are positive slope. So these are our slopes. This one is a negative slope. If you have a negative value, the slope goes down from left to right. Now we just learned if a line goes straight up and down, it is undefined. And we learned how to prove it. We basically proved that a horizontal line or a vertical line, well, I don't know if we proved it, but we showed it. We showed it pretty convincingly, at least, that lines that are vertical go up and down have an undefined slope. And if you recall from the lesson a couple ago, if you use this same strategy, you can use the same formula and you can show that horizontal lines have a slope of what? 0. Right? They have a 0 slope. And 0 and undefined are very different. 0 is a number. It is the number 0. Whereas an undefined slope has no number representation for it. Okay. Great learning. We are cranking through lesson or module 4. And we have we're about halfway through module 4, 8 and 4. And this is the longest module of the year. This is algebra, this is geometry, this is connecting the two of them. It's about slopes. It's one of the most important things you learn in 8th grade math. So hopefully this is all working for you. Hopefully I'm helping out. And if I'm not, let me know. Send me email. Leave me a link on, or leave me a posting on the YouTube channel. Give me a thumbs up. Subscribe. Tell your friends to subscribe. And other than that, I will see you next time. Oh, you're welcome. I'll see you next time, lesson 17. Talk to you later.